I'll take your mic. Hi, I'm Kathy.
Yeah.
This is Sandra. And we really look forward to teaching you about dragonflies. So let us get behind our podium here and where I can advance some slides. So, yes, marvelous dragonflies. Oh, if I turn this on, it'll work better. There we go. So, Sandra?
So tonight we'll be covering the beauty of dragonflies. A little bit of anatomy and biology, as that's important for not only knowing about the species, but identification. Some of their necessities, such as habitat, their role in the environment. And then we're going to quickly go through a few of the Mendocino species, and then we'll talk about some of the resources that are out there for you.
So I'm just curious. I gave a program here maybe a decade ago, maybe 15 years ago. How many of you were there? Okay. Not okay, because this slide I'm going to show you is the same one I think I showed then. It's still in my program. Dragonflies come in all the colors of the rainbow. There are red ones and orange ones. There are blue ones. There are green ones. If you go to Southern California, there are pink ones, and there are yellow ones, and there are ones with metallic coloration. I want you guys to memorize this one because there is one county record for it from 1975 for 15 miles west of Laytonville. And Dave and I went out maybe a decade or so ago and tried to refine this species. This would be the very southernmost point it's ever been recorded. So you're tasked, okay? This is the river jewelwing. And he's metallic, he's blue-green, and he's just gorgeous. Some dragonflies have clear wings. Others have patterned wings. And they come in different sizes. All of these are found in Mendocino County. And there are dragonflies with curvaceous bodies, and it's the guys that have the curves in the dragonfly world. And they can do some pretty amazing things, both in their flight and in their biology, which Sandra and I will be going over more soon. So dragonfly anatomy.
So dragonflies are insects, and so they have three body parts. They have a head, a thorax, and an abdomen, which is often called a tail, so, and especially in their names. Their head is almost all made from their eyes and their face. The thorax holds all four wings and 6 legs, and the abdomen has 10 segments, and that's really important for talking about identification and where we find field marks, and they're numbered from the head to tip all the time. But I will tell you, we forget this, but a lot of things are found on segment 8, 9, and 10, and it's easier to count 10, 9, 8 than to start from 1 to 8. So you think that's obvious, but it's not. Next.
So I'm going to talk to you about the head. This is the green darner's head, and these are his eyes, which are huge. If our eyes were comparatively large, it'd be like we had a football helmet.
Wow.
Yeah, I think I'd have a sore back. They have these great big eyes because they're predators. And each eye has 30,000 facets. You've probably seen pictures of houseflies' eyes.
Yeah.
4,000.
Wow.
This is a big difference. And they're able to see flickers of light twice as fast as our eyes. And Dave and I and Sandra all think that when we tighten our hands on a net when we're doing research, I swear they see our muscles tighten. And they see both polarized and ultraviolet light. So what we are seeing in them is not necessarily what they see in each other. So here's a little close-up of the dragonfly eye. So these different colored spots are multifocal places. And so here's one of them, and you can see all these different facets. So with these eyes, they can see above them, below them, and of course in front of them, and to either side without even moving their head. And some dragonflies have built-in sunglasses. So it's something you can watch for. I just think it's amazing that a critter who's been on Earth for over 300 million years has built-in sunglasses.
And that's that darkness we see, Karen, there?
Yes, this dark area, I think of it as a built-in sunglass. I've never heard a scientist say that. That's my thought. And the head has no nose. If you were to behead it, it would not die. It would live with no sensory input. It wouldn't fly, it wouldn't walk, it wouldn't do anything. It would just sit there. But it would stay alive until it starved. And Sandra will be talking about how they actually do breathe. The mouth is below the eyes. Mine goes up and down. Theirs goes sideways. Can they bite? Well, of course, they're predators. But a dragonfly will never land on you to bite you. Not something to worry about. In fact, this is about the only way we can get them to bite us. We hold out our finger and we restrain them and we put their mouth on our finger. And I'm going to put this down for a second. Oh, yeah, Sandra. So take your finger and give yourself a real swift pinch. It's just enough to startle you. So I'm looking at one, studying it, bites me, I startle, off it goes. So not to worry about dragonflies biting. And they eat the most dangerous animal in the world. Think malaria, dengue fever, West Nile disease, Zika, yellow fever, and more. So that picture was from my coloring book that Tim Manolis and I did. I asked him to draw the last thing a mosquito might see. And here it is. So they're the odonata, the toothed ones. Here's the teeth. They don't suck the juices out of their prey. They chew it up and swallow it. So I think that's a pretty cool picture, and it's in the coloring book. And when I gave this program here last time, I might have said, we don't know what they have antennae for. But now we know they're sort of like their speedometers, that they help them gauge how fast they're going. And Sandra and I learned in June that the nymph, who also have antennae, use them as chemoreceptors. And so there's things we're just learning, which is kind of the fun thing about getting into dragonflies. You're kind of on a cutting edge. The head's very loosely attached. You can see a lot of empty space here, and that'll come into discussion again soon. And I'm going to let Sandra talk about the thorax.
So the thorax is basically a parallelogram and is the powerhouse. It has all four wings attached that are individually muscled. And they also have the same flight pattern that hummingbirds can do, that figure eight. So you can imagine the kind of acrobatics that they can do. And in that little spot there, there's one here with the arrow, but there's another one here, and they're throughout their body. That are sphericals, that's where they breathe from. They don't have a central nervous system, and they don't have a central breathing system. So as they move their wings, it creates a pumping mechanism that allows the air to get pumped in and out. So, like I said, the thorax has all four wings, all individually muscled, and they're also solar powered. They need a certain amount of temperature to be able to move, and so they will spend a lot of time in the sun gathering heat. So the thorax also has 6 legs, but every once in a while it looks like they only have 4 because they use them kind of like these little shields to protect their eyes. So there you go. And here again, they're using a shield for their eyes here, so they look like they're four-legged, but they're definitely six-legged. They also use their forelegs to clean their eyes. They are predators. They have something like a 95 to 97% success rate in their predation of other insects, and one of the main reasons is the eyes, but also their wings and acrobatics. So speaking of wings, they have four, and all of this used to be, when we used to do ID, they'd be done in a museum with dead specimens, and so they really got into all of venation. And there are a couple of species that still to this day we need a little bit of venation to tell the species apart. None here in Mendo, but they are, they kind of bend and fold in ways that create wonderful aerodynamics besides just the figure eight. They have a lot of control in how it bends and therefore bends the air for their acrobatics. And they are the strongest part to be able to hold them. Unlike butterflies, they don't have any scales or anything. So except for when they first emerge and are not completely dry yet, the best way to hold them is by the wings. So here's a little video. You can see how they're independently muscled. And here's another breathing area. So again, the more they move, the more air they get, the more oxygen they get. They've had a long time to figure out how to do all of that.
My turn again. I'm going to talk to you about the abdomen. So always 10 segments, always numbered from the head towards the tail, and these segments are loosely jointed. So they have to be able to do this, 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 both in their flight and in their biology. So they need to be able to move. Thanks, Sandra. And females have two appendages at the end of the abdomen, and these appendages are not stingers. They can not sting. But they have learned, if you're holding them and restraining them, to go like this at you. And I have held them in my hand, and my brain is saying, let it go, let it go. And I know that it can't sting me, but they've learned that this works. Then the males have another third appendage and a bump under their second segment, which shows better in this slide. So if you would think of this area right here on this guy as a Swiss Army knife with multiple tools. We'll be getting into what those tools are and how they're used later. And we often use the shape of the appendages to tell some of the darners and some of the other dragonflies apart, but of course that isn't why they have different shapes. So dragonfly courtship is kind of caveman style. He's sitting on the pond waiting for her to come in and lay eggs because he's going to waylay her when she gets there. And she's coming in and thinking about nothing but laying her eggs. But he's a little, maybe a shot of testosterone. He has other ideas. He chases her down and he grabs her. And he grabs her using those appendages behind her eyeballs. And when he does that, if he is the right species, it feels good. And she wants then to mate with him. He kind of turns the key in the lock. So it's pretty fascinating. So now we know how they get together. So once they get together, so the male will use that Swiss Army knife and will take away any sperm from a previous mating before putting in his sperm. And then she'll go and lay eggs right here. And then this looks like it's on a lily pad, but this is underwater. This is a nymph, is what we call them when they're underwater. They'll go through between 14 and 17 molts. And then eventually they'll find a stem. Usually it's a stem. Sometimes some species come out on rocks, but usually there's some emergent vegetation. They'll crawl up, and then we're going to switch over to here, and they'll bust their backs open and come out, and we'll show this into detail in a little bit.
And then they'll eventually fly, and then they start the whole mating process all over again. So here's a close-up, the tandem pair. So they're tandem because they're still hooked up together. And you can see how his appendages are locked like a key into the back of her head. And here you go. So all that space here for this. Now in damselflies, which we'll talk a little bit more about later, they hold on here. Slightly different, but still basically the same thing. When they're mating, they do this wheel formation. When you see insects, usually you see them end to end, but these guys still make their sperm here in the 8th, I think, segment. But they have secondary genitalia here, and this allows them to do this wheel. And Odonata, the dragonflies and damselflies, are the only ones that do this, and they can fly this way, both facing forward.
Truly flying united.
Truly flying, yep. So here's a closer look. So here's where the male is holding on in the back of the eyes, and then here so once she feels like this is somebody she wants to mate with, she'll bring herself forward and they'll attach here, and this is where the sperm transfer will happen. And when they're doing that sperm removal, you'll see them, sometimes you'll see them encircle like that on a branch or something, and you'll see them do like this little shimmy, and the shimmy is the removal of the sperm. And then there's some dragonflies that have this waxy layer that turns them white or bluish, and they'll have these little spots that are darker, and it's basically the wax is shined, and so you can tell whether the males have been successful in mating, because the only way the wax would be shined, and we'll show you a picture of this, is from where these legs of the female are holding on to the male's abdomen. So because of this removal of sperm, the male wants to stay with the female and guarantee that no other male will take him. And sometimes you'll see some fights. You'll have these males coming in trying to knock him off. And many of them will lay eggs in this position in tandem. And so here she will tap her hind end into the water, and he will stay attached. Sometimes they will hover guard, which is where the male creates a territory above the female that's laying and try to keep the males away that way. And so here's a female with eggs. She's extruding eggs here, hundreds of eggs. They lay tons and tons and tons of eggs. And here they are in Kathy's pond. This is a dandelion seed, and here is duckweed. And every single one of these white dots and black dots here is a dragonfly egg.
So the nymph that hatches from those eggs looks kind of like a six-legged spider. And they have a really cool, extendable lower lip. Yes. All of this would be our lower lip. And and they have to use slow motion photography to even show it to us, because it's lightning quick. And they've been here a long time, and boy, I think that's pretty advanced. So one day I looked out my kitchen window and I saw this little brown thing, and I got my binoculars out and I said, ooh, it's a dragonfly nymph. I think it's going to emerge. So I waded in and I picked the leaf of the mare's tail and put it in some water, and I put my camera on a tripod and got this picture. So this dragonfly nymph has split open its exoskeleton and is now hanging limp from it. Birds love it when they're like this, totally helpless, nice and juicy. So they can stay like this like 45 minutes or so, depending on how warm it is and how humid it is. The legs have to harden so that it can lurch forward and grab hold of the exuvia and pull the rest of the abdomen out, and then start the metamorphosis with the wings expanding. So here the dragonfly has come all the way out of the exoskeleton, and so here's a new word for you, exuvia. Once this is left behind, it's the exuvia. So can you see how this dragonfly is already twice as big as what it left behind? Yeah, he's pumping himself up like a balloon. And then the wings are being pumped up.
How long is the entire process?
It really depends on the weather and the temperature.
And the species.
And the species. So here it's got its wings finally completely expanded, and then it opens them for the first time, and we call this a teneral. And it's a cardinal meadowhawk, which is a bright red species. But just like our young birds are more cryptically colored because they're safer that way, that is true with the dragonflies also. And male dragonflies, when they emerge, look very much like the females of the species. And as Sandra mentioned, the teneral is the one time you don't want to hold it by its wings. When the wings are glossy like this, they would stick to your fingers and to each other. So Sandra, do you want to talk to them more about this?
Yep.
We get to do this dance here.
So, so with a dragonfly nymph is the aquatic form. And just like the adult form, they have 10 segments. And then eventually, they grow these little wing pads. And you saw how when they came out, you couldn't really see wings. And then they pumped them with hemolymph, a lot like butterflies do. And they also have these antennae. The eyes are not as big, but still really large as far as insects are concerned, or aquatic insects are concerned. So a little bit difference between dragonflies and damselflies. The dragonflies are much larger and more robust, and those are the ones that you tend to notice a lot more. Their forewings and hind wings are a different shape, and that larger hind wing really allows them to glide. So they can travel some decent distances, some of which even migrate. And then the damselflies are more like the needles that are down by your feet and your knees, and when you're kayaking, they're landing on your kayak. And they really are tiny like needles, and their forewings and hind wings are the same. Their eyes are somewhat different. They're large no matter which species. However, in dragonflies, they either meet at the seam in the middle, which is one of the ways that we can differentiate families. Or if you could, to have them all touch, you could only just add one eye. In damselflies, you could add 3, 4, 5 eyes in here before they, oh no, go back.
Turn it, yeah,
there we go. Before they meet, so they're kind of more like a hammerhead shape. And then they also have these little eye spots here that we can also use for ID. That can be important. I mentioned before, when they're breeding, the clasping point, the female gets taken by, held by the back of the head in dragonflies, and what's called the protothorax, or the front of the thorax, in damselflies. But it's still very much like a lock and key sort of system.
So all dragonflies and damselflies are carnivores. So this is a spiketail. She's eating a yellow jacket that she caught above my pond. Took her 45 minutes to eat it. Wow. I got on a chair and I walked all around, moved it around and took pictures. It was really amazing. And of course they eat lots and lots of mosquitoes. The damselflies are more like our warblers. They're gleaning insects off of leaves. And all dragonflies need this aquatic stage. So different kinds of waters are needed. So lowland lakes, my dragonfly pond. Actually, I built it for wildlife and dragonflies showed up. I didn't build it for dragonflies. Highland lakes, the nearest near you might be Plaskett Meadows. Rushing waters and slower waters, streams and fens, all different kinds of dragonflies need these different kinds of water. So where you go near water will depend, the different species will be found there. Rivers mostly have clubtails. You're not finding, very few clubtails will go to a lake. And we'll show you the difference between the species later. Who eats dragonflies? Well, of course, our beloved birds do. And this one guy, Mark, he had a whole website about birds eating dragonflies. And so here's a heron of some sort eating a red saddlebags, and I noticed it grabbed it by its juicy eyeballs. Almost all predators like the eyeballs best, I've noticed. And not only do birds eat the flying dragonflies, they also eat the nymphs. So this is the underside of a common green darner, and this right here, that's that lower lip that's folded up, waiting to be shot out. Can't do it much good right there, though. Of course, frogs try to. And believe it or not, spiders. This is a large darner, almost a 2 or 3 inch long dragonfly caught in this orb weaver's web. I don't think she needed another meal the rest of her life. Sometimes other dragonflies do. This is called the pond hawk because of that. It's known to prey on other dragonflies, other carnivorous insects, especially the robber flies. And for little damselflies, even carnivorous plants can be a problem. They have many known predators, but of course habitat loss and change is really a danger to them. Think about the multi-year long droughts. The ponds dry up, the lakes dry out, the river flows change. Then we have the big torrential rains, and not only do the highways get closed, we had 5 stops on the way here, 5 places, but also the maybe get washed out. So these are all dangers for them. Sandra is an expert on migration. You have one of the world experts right here.
So many people don't know that dragonflies migrate. Perhaps if you've done hawk watch, you might have seen a kestrel with their to-go meal. So I'd like you to ponder a little bit the fact that dragonflies have been on our planet for 300 million years or more. And so who migrated first? And I don't think it was in any of the books in college, and nor have I seen it anywhere else. But I posit that since the dragonflies were here when Pangea was still around, and as everything started splitting apart and they were trying to maintain habitats between different distances and timing of the seasons, then once birds came along that were eating them, they followed them during their migration and learned to migrate. So just another theory out there, but I think it's a pretty good one. So the common green darners are the species that we know the most about migration. I will say we are still at its very infancy of even understanding dragonfly migration. So Kathy circled a bunch of these little white dots, but if you look carefully, it looks a little fuzzy. It looks fuzzy because every single one of these little white dots in here is another dragonfly. So in 2023, I was able to go to Ohio and join a team where we put Modus tags on dragonflies. This was a feasibility study, and we learned a lot. We had some glue issues. At first, it was finding a glue that wasn't toxic. Because when you use Modus tags on birds, you put it on the feather, not on their skin. And we had weight concerns, and the antenna was way long and all that. And we're like, well, okay, so maybe this isn't going to be that great. But then we learned about blue morpho tags that run on Bluetooth. And they're even smaller, and they have solar ones. And remember I talked about how dragonflies themselves are basically solar powered. So here now we can put it on their back, and on the back of the abdomen here. We glue it on, and they go out in the sun every day to warm up, which means they recharge their battery every day. There's a little $250 equipment addition we can put on the existing Modus towers. And now the technology has gotten so good that you can go around with your phone on Bluetooth and scan for any of them that are nearby. They're using this with monarch butterflies. And so just kind of like your luggage tags with your phone, basically we can do this with these tags. And Amy here, who's releasing one that we just put a tag on, led this effort. And Melissa here as well is helping. And we were funded by the U.S. Forest Service international programs. And so, of course, we lost the funding. But we hope, we do now know that it's feasible, at least for the larger dragonflies, to be able to put them on there safely. And we feel that there's really good potential for being able to study migration once we can get some more funding and continue the process of learning. Dragonflies have the longest migration in the world. They go from India through the Seychelles into Africa and back. They do this in multi-generations, and we still don't really understand the mechanism of that, but it is pretty darn amazing. And there's this TED Talk, it's pretty old, it's from 2009, but it's absolutely excellent if you're curious about how they figured out that these dragonflies were even migrating, and how wonderful that whole process is.
We have a question. Do you ask you now or wait till the end?
I think we usually take questions at the end, so try to remember your question. So you have 61 of the 114 known California species of dragonflies here in Mendocino. All the families that are found in California are found here. There are 7 families of dragonflies, and you have 39 species, 3 families of damselflies, 22 species, and I'm really happy that Dave and I and Ron LaValle, who made a lot of the records for Mendocino County. So I'm going to talk to you about the skimmers. The nice thing about the skimmers is they perch. And therefore, you can get your binoculars on them or your camera. If you want to learn the dragonflies, I recommend taking pictures of them and then going home and looking at them, because they're zigging and zagging around so quickly that it can be really hard for a beginner to learn them. So the skimmers are the most common. We have 21 species of skimmers here. They come in all the sizes. A common one is the flame skimmer, Libellula saturata, saturated with color. A lot of scientists gave names to insects looking at dead specimens, and they named them after some tiny little microscopic piece. But whoever named this one, they saw it alive. There are 6 different Libellula in Mendocino County. Another one that's an early spring one is the 8-spotted skimmer, named for 2 dark spots on each of its 4 wings. And the common whitetail used to be in the Libellula family, but like with birds, we get splitters and lumpers, and it was split off into Plathemus about 20 years ago. Then there's the meadowhawks. I'm sure, who was telling me their pond has dragonflies? I'm sure this is the one you've got for sure. The cardinal meadowhawk, named after the bird, the cardinal, and the bird, the cardinal, is named after the Catholic cardinals with their pointed hats. And there are a lot of different meadowhawks, so we use the white dot on the side of the abdomen here to identify this one. Of course, sometimes you can't see that through the wings. Then you have a black saddlebags and the red saddlebags that we showed as bird food earlier. And then there's the blue dasher. And this is one, like Sandra mentioned, they have this waxy coating that they make it. So when he first emerged, he looked like a female. He was kind of a plaid color. And then this blue wax coating, starting at his tail, obscured all those marks. And he is a studly guy. Look at it. So many females have agreed to mate with him that they've just rubbed his wax right off. So this is a western pondhawk. This is the female, but a young male would look the same, and then he develops this waxy coating over his abdomen, obscuring everything except the green on his face eventually. So to tell these two apart, you look to see if it has a white face or a green face, and you try not to get confused by the eye color, and if they face you, it's really nice. There are ways to tell them apart, even from the back, and we go over those in our guide. If you go up to the mountains, it's a whole different cohort. And if you go down to the Southern California and the deserts, even other species, although the desert whitetail will be found in the Modoc Plateau area.
So the emeralds are named for their emerald green eyes. They tend to be more mountain lake species, but some of them do come down almost all the way to the ocean. They have these really metallic, they really do look like jewels flying in the sky, and they're really amazing. But the rest of their bodies are really much drab and brown with maybe a little bit of yellow on them. And they kind of look super hairy, and that's true both in their adult form and their aquatic form. The species that we have here is the beaver pond basket tail. They're probably one of the more colorful ones with all of the yellow on the sides. And then the American emerald. So here we're back to just plain old brown with this little yellow line, but the green eyes are unmistakable.
Okay, then the darners. Sandra probably felt happy. So many programs we give, they don't have many emeralds, but you guys with Plaskett Meadows, I guess that's actually really in Glenn County.
Yeah.
Yeah, but you have some of the other emeralds. So there are 6 species of darners in California, but this is about all you usually see of a darner. Often we say, oh, darn it, there went a darner. But if you could get a camera that would take a picture like this, this is a shadow darner, this is a male. They are multicolored, often with blues, sometimes with greens, and the females are differently colored. There are 3 species of mosaic darners here in Mendocino County. And then split off from them in 2003, we get the neotropical darners, the rhino eschna. And this is the blue-eyed darner. He is so gorgeous with that blue eyes, blue stripes on top of the thorax. And this is the shape of his appendages, because I don't show it to you, but in our book you can see the California darner, and it has blue eyes also, but not quite this blue, and it has a dark line on the face, and its appendages are very simple shaped. So there's a lot of little nuances you need to get into. And then there's the common green darner. His name, Anax Junius, means Lord and King of June. And he is about 2/3 the size of this one that I have for display. But this one is correct except for being a little oversized. Usually seen in flight, but you can tell this one from the others. You've got good birder eyes. You're already used to looking at motion and seeing things. You've got the good skills. Sandra, you're on for the clubtails.
These are the sexy curvaceous ones that she was talking about. The males have these like club-like abdomen especially when they're sunning like this. This is called obelisking. When it's too hot, they will turn the tips of their abdomen to the sun, therefore creating shade for the whole rest of only the tip of the abdomen gets sun. The rest of their abdomen is now therefore shaded. And then every once in a while you'll see them in this position if the sun, say, was over here and it was cold and they're trying to bring as much of their body to look at the sun, kind of like we do with our solar panels, right? So they do that naturally. But these are rather large, and these are the ones that you'll see along the rivers. And some of them will fly back and forth across the river. Some of them will fly up and down the river. They tend to be in the sort of brown and yellow coloration. And you will sometimes see them at ponds, but really the bigger, faster rivers are where you will find them. And very often in the middle, the rock in the middle of the stream. The females very often in the bushes or down logs on the side or away from the stream, but the males right on the rock. And sometimes you'll be looking, and you'll see this as you're kayaking. You'll look way ahead and you're like, oh, there's a bunch of bird poop on that rock. And as you get closer, all of a sudden the bird poop flies off. So pay attention. So here we have the gray sand dragon. overall gray, especially from the side. The thorax is all gray, but has a bit of tame yellow. And again, this real club here at the end. And the appendages are super yellow on this one. The female is much, much grayer and drabber, as many of the females are.
And I just want to mention on that gray sand dragon, Dave and I got the record at the Kate Wolf Festival. In the swim pool back there behind the stage.
Oh, fun. Here we have the bison snaketail, probably one of the more colorful. In this bright green is hard to miss, and especially with the super broad shoulder stripe. And it is a type of snaketail. And if you look at them from the back, this looks like the head of a snake. And so there you can see how they got that name. Then we have the Pacific clubtail. Again, the club part of the tail. They have these really amazing eyes that are almost like pendant shaped and a lot of space in between. We have the white-belted ringtail, which is more of a southern species with bright, almost rusty-colored head to the club and very colorful striped thorax. And the grapple tails are one of my favorites, named for these grapple-like appendages that are bright yellow. These guys you'll find in these little streams that have dappled shade, and you'll be looking and you're like, oh, there's nothing down there. And then you're like, what was that was moving down there? And then if you get your binoculars down there, it's these guys.
My turn again.
Yep.
There are 3 more families, but they're all black and yellow, so I've grouped them together. There's the petal tails, which those of you who were with us at dinner heard more about them, the cruisers and the spike tails. They're really not related. This is the black petal tail, named for the petal shape of his appendages, associated with serpentine soils and Darlingtonia plants. So if you can find those, look for the black petal tails there. So,
But in the southern region of their range, you don't get the Darlingtonia. You just get the serpentine seeps.
So look for this. There are no iNaturalist records, but there are 3 specimens in different museums, so they are known to occur here. None along the coast, I'm sorry. They're more inland with the serpentine soils. And then there's the Western River Cruiser, Macromia magnifica. Oh yeah, whoever named him, he'd been in a river when one flew by. They are powerful flyers that go up and down the shorelines of the river. And if you're waist deep in the river and one goes by about your ear level, you actually hear their wing beats. They're so strong. Their nymph have these big, long legs. And you will find their exuvia on bridge supports. So look for those. And then there's a Pacific spiketail who's got this beautiful blue eyes and 2 stripes on the side of his thorax. If we go back, the Western River Cruiser has 1. So you have to learn to look for these things. And now Sandra's going to talk to you about the damselflies.
The little needles by your feet and your knees. They are really tiny, and that makes them a little bit harder to enjoy and really look at. But remember, their eyes are set further apart. They do have those little eye spots, which we'll look at a little bit later, which help with ID. And the females have this expanded tip of the abdomen that almost looks like a mini club. And they're weak flyers, so as soon as those starts to get windy, they're down in the grasses, staying protected. So first we have the pond damsels, and we have 6 Mendocino genera and 15 species. They're tiny, which means when it gets just a little bit warm, they're out right away because it doesn't take much for them to get warm, but it also doesn't take much for them to get cold. So, but they're often the very first ones that you'll see in the day because it takes so little sun for them to come out. A lot of tan in their bodies, but lots of blue, especially in their thorax and for the males on the tips of their abdomens. We have the bluets. They're mostly blue. And I want you to pay attention to this wing position here. The bluets and all other pond damsels have their wings, when they're held to the side here, they go along the abdomen. The abdomen splits the wing in half. So they mostly are perchers along ponds in very slow water streams. And we look at how much black or blue there is on the segments. Is it mostly blue, or is it mostly black up to the middle part of the abdomen, or S5 as we call it for this fifth segment? And their eyes are black on top with these little blue eye spots. And with the shape of those eye spots and whether they meet or not, or make a dumbbell shape, we can tell what different species they are. And here's a whole congregation who see these here. You have them in tandem. Remember we looked at those on dragonflies. They also do things in tandem. And a lot of times you'll see these on the edge. I don't see one here. When the female will be laying the eggs underneath the leaf and the male will still stay attached. I'm sure you guys have seen that if you've been up and down the streams here. Argia are the bigger needles. They're very colorful and bright, very bright blue. They can turn almost purple, and the color changes with temperature. And as well, some of the species will change color if they're recently mated. The females will stay brown during that process. Their wings, if you look, are above their abdomen, clearly above. And so I think of them as ballerinas. If you know somebody that's a ballerina, they always hold their arms away from their body. So they're dancers. They have dancers' wings. They hold them away from their body. And then they're very often in slow-moving waters. And this is one of the ones that you're going to see the most often, because very often they're away from the grasses, next to the streams or on logs, and they're so bright blue and a little bit bigger than the others. And they have the cutest little faces. I am in love with these faces. But just see how blue these guys are. They're just amazing. Now the females are going to be brown, but the males are really colorful. Okay, come on. So this is the most common dancer. They have these little triangles here, and in this part of California, the triangles are diagnostic. The females are brown. They look like this. They also have the triangles. So there's a difference. There's one where it looks more like a little stripe, and you might think are triangles, and that it's only probably in identifying as the females. But if you've got a male with these triangles, you already know the species. And here's one purple. That's how deep purple they can get. And this particular one, Emma's dancer, this is their typical color, and they can get a little blue.
Yeah, they'll be on the rivers.
Yes, they'll be on the rivers. That's correct. So again, wings held above the body for a dancer, and through the body for the bluet. Then we have the tiniest of the tinies. These are so small. They're mostly black and blue, but also have a lot of green and sometimes yellow underneath the abdomen here, and almost always have a little blue at the tip of the abdomen. Whoa. Their wing position is variable. Usually at least part of the wing goes across the abdomen, but they're also so tiny. You can't mistake them for a dancer once you've seen a few. Oh, and the female sometimes becomes prunos. Prunosity is that term for that waxy layer that we talk about. And it's the same family there's a family of waxes. It's amazing what you learn when you get into the woods of these things. They're in the same family of wax as your plums in the store. So you know that hazy color. So it's just a much more solid version of that, and that's why you can buff it and shine it, for those males. So the most common one we have here is the Pacific forktail, and the males are awesome because they're the only ones with these 4 little blue spots on their backs, and you can see that really well with binoculars. And if you're young and have really good eyes, which I'm starting to not have anymore, you can see them even with your naked eye. And then the Western forktail also has these bright and very linear stripes on the back of their thorax. The western forktail, the females, becomes prunos, which is a little switch up. Now, the Pacific forktail females, they have 1,000 dresses that they like to wear. The males have one suit, that's all they wear, and the females have 1,000 dresses. And so for me to identify the females, I rule out all the other forktail females. And once I've ruled out the other forktail females, I know that it's a Pacific forktail. They're just really variable. The swift forktail has these really amazing appendages that are just long and hooked, and they look like they could grab onto just about anything. They have a lot more yellow underneath, and they tend to be in areas that have just a little bit swifter water. And I don't know if that's what they were named after, but
Yeah, I wanted to interject that Dave and I found our first
There you
ones
go.
ever at the Botanical Gardens here, and we're hoping to find them there tomorrow.
excellent. It's, we've had a really warm spring, and things are coming out much earlier. So when they come out, they're underwater, right? And the speed at which they grow is dependent on water temperature and how much food they have. So long as there's enough food, when the temperatures go up, they're going to come out earlier in the spring. And this is one of those years where we're going to start getting things really early compared to other years. So they should.
So she always has to let me talk about this one. This is the exclamation damsel. And it's a California endemic, and it is found here in Mendocino County. When the naming committee named dragonflies, gave them common names in 1996, since this was a California endemic, they thought, well, let's call it the Sierra damsel. Well, guess what? Sierra might mean California to people in the East, but to us, Sierra means the mountains. And it's a valley species. And this turned out to be the first one I ever identified by myself, and I always use 2 blue exclamation marks. And I complained to Dennis Paulson, some of you may know him through his shorebird guides, that it was an inappropriate and misleading name. So he said, this summer we will entertain new names. So Dave and I, Tim Manolis and Andy Wren, who is getting his PhD in ornithology, we batted names around. Well, they like to be in the dappled shade on the blackberries. Let's call it the shadow damsel. Nope, taken. And that went on all summer. And finally we said, well, its scientific name is Zonagrian exclamationis. That's got to be referring to these exclamation marks. Let's call it the exclamation damsel. The vote was not unanimous, but we did win. And so, yay, I got to name a damselfly. That's pretty exciting. And you have it here. It's going to be on mudlined creeks. Then there are the spread wings. This is another whole family of damselflies. And you can see why they're called the spread wings. They spread their wings. There are 6 species here. You have 3 species of pond spread wings and 2 species of stream spread wings. And this, the great spreadwing, is Northern California's largest damselfly. It won't be out till the fall. Although I think there is a March record where there's another, it's the end of the season for it.
There's always an outlier.
And then there's the broadwings, the jewel wings we like to call them. This is the American ruby spot. When you're going on that kayak down the river, this is the guy who's going to be landing on you for sure. Just absolutely beautiful. In California, we only have this one species, the American ruby spot. You go down to Mexico, they've got about 10 species.
Since we're with birders, I'm going to say that they have lecking behavior. So that's fun to watch. The males dance and flit over the river, trying to impress the females.
And here we're back to this one. This is the one I want you to look for. This is the river jewelwing, Calypteryx aquabilis. There's no agreed way to pronounce the scientific names. So anyway, there was the one record from 1972, 15 miles west of Laytonville. And I think there might be a field station there. Yeah, So look for it there. I would love for you to find it. It's an early season flyer. This year I would look for it in June. So we hope you've enjoyed the presentation. Sandra's going to talk to you about resources.
So, so of course we have our guidebook, and we encourage you to buy one of those. It has all 73 species in California and is the first dragonfly book to include nymph and exuvia of at least each genus. And we are looking for more pictures of confirmed species, exuvia, and nymph to add. We would love to eventually get to the point where we have every species, but that's going to take some years. You can get them on Amazon if you like the perfect binding, but we have the spiral binding, which is really nice because you can really open it up flat and do all that, and we have several available for you today.
And I brought a few with the perfect
Yeah, we do
binding
have some perfect bound with us as well.
for your bookshelf.
But there's a picture of both males and females of every species in a large format. Kathy and I talked about this at length. I talked her into doing somewhat predictive field maps or range maps. And so far that has turned out really well because they've already filled in some areas that it would have been wrong. But we are finally getting to the point where we have a decent idea, just now have a decent idea of where their ranges are. And so that's something to keep in mind with some of the older books. You guys might know Dennis Paulson from his work with shorebirds. He has the definitive guide on dragonflies and damselflies. It's a wonderful, super book with every species in North America, west and east, and it is in scientific jargon all the way. So do not start with this book, but if you're going to get serious into dragonflies, it is a must-have. Another excellent book is Ed Lamb's book. This is what a lot of birders will be reminded when we had plates with beautiful paintings and drawings. And so he gets to really get into the nitty-gritty of each species. It is for the whole of North America, and so it covers all 329 species. So if you're just going to be in California, this might be a lot to start out with when you're a beginner, because you're like, oh, it looks like this one, and then you find out it's only found east of the Appalachians, you know. So some other older books that you might find, these books on the right here, these Common Dragonflies of California, these were Kathy Biggs' first books, her pocket guide books. She had a big 3D ring binder with everything she could get off the internet with notes and pictures, and she's like, man, there should be a book. And somebody said, you have the book right there. So this is how she got started. And she does both California and all of the Southwest. And she does have a couple of the Southwestern United States books left over. They're out of print. So when she runs out, how many do you have left? Like 10?
No, more like 50.
50. Oh, you found another box under a bed somewhere. This other book here for Tim Manolis is also an excellent book, but it's old now. It has all of the pictures in the middle, and they're excellent, and they're really good for ID, and the descriptions are still good. A lot of the names are old, and the maps, we had no clue back then. And it was the best that they had at the time, but we were still doing blitzes all across the state, just trying to fill in the maps. So don't pay attention to the maps in here, but other than that, the ID and everything else is excellent. And you can find these in used bookstores quite often. And I think you can still technically buy them new. If you're into e-guides, Kathy's Southwest Guide is an e-guide, and so is Dennis Paulson. I'm a gotta leaf through it, write in it type of gal, so they're not for me, but some people like them. And you can carry them on your phone that way. And then Kathy has her Color and Learn book. The pictures are all anatomically correct, and the correct coloring of them is on the back. So if you're the type of person that needs it to be perfect, you can. Or you can do whatever you want. And what does Kathy like to say? It's for
It's for your grandchild, your child or your inner child.
On the web, of course, we have other resources. Odin Central is the repository for all of our county and state records. Very part-time volunteers here in California. There's some other states that actually have people that get paid for it. Kathy and I are 2 of the 4 very part-time vouchers. And it's quickly changed because now it's linked to iNaturalist. But iNaturalist has its issues, but is still excellent. And in the Dragonfly field of iNaturalist, it's actually really good because Kathy and a couple other people are experts, and they actually check it regularly. And every once in a while, somebody gets the ID really wrong, and people pile on and say, yeah, sure, that's what it is, but they don't really know. And so then she puts the call out and says, come on, everybody, we need to overturn this ID. So we have done that. For Dragonflies, iNaturalist are really good. The AI is got some work to do, but it's getting there. Kathy maintains a Dragonfly website. It has additional photos, additional keys, and she maintains the maps, the range maps. And those maps are not predictive. Those maps are where they've actually been seen. So they might be a little different than what you see in the book. If you're still on Facebook, I started and maintain Western Odonata. We have beginners, experts, photographers, just about anybody on there. It's a really good place to learn and ask questions. And I don't remember this page.
So we have web resources. There's copies of them on the display, but you can download a checklist of California's dragonflies or also a migratory dragonfly slide booklet from the website. That's all.
And then again, these are the books that are available. Here is the tiny URL link to get to these. And we are selling these tonight for 35 buckaroos.
Tax
And
included.
No tax and no shipping. So, and then Kathy, again, she just brought back her full-size coloring book into print this year. So if you like to do that, we really encourage it. And that's it.
Yeah. So, thank you. Do you remember your question now?
Some of them, yes. So, did they just mate one time?
Do they just mate one time? Well, no.
She has
How long is their life cycle?
Oh.
trick question.
Love that question.
So,
For the Zoom audience, can you repeat
Oh.
when someone asks a question?
Yes, thank you.
Zoom question.
Yes. So the first question was, do they mate more than one time? And yes. And then the second question was, what is their lifespan? And that is weeks to years, depending on the species. And when we say years, it's years in the aquatic phase. They're only in the aerial or terrestrial phase for weeks to months. And underwater, it's months to years, depending on species.
and on the mating issue, she will probably receive enough sperm in one mating to fertilize her whole lifetime of eggs. But the guys have other ideas. Other questions?
What do the nymphs eat?
So they're carnivorous. Oh, what do the nymph eat? They are carnivorous both in their aquatic phase and their terrestrial phase. And if you want to see some pretty amazing stuff, you can go on YouTube and look it up. People film them in aquariums. And some of the larger dragonfly nymph can actually catch little fish. And those are the most amazing videos if you're into that kind of thing. But yeah, just basically anything they can catch. They're not really picky.
Yes?
What's the fastest that one's been clocked?
The fastest that one has been clocked is about 35 miles an hour. So people find them out in the desert. They're there feeding, and they can just then fly back in to do their mating later.
And I have a friend of mine who's a bicyclist, and he gets them right next to him quite often as he's going down these back roads. So yeah, they can really go pretty fast. The bigger ones.
Yes.
The migrating ones, how long is the migration cycle and how many generations does
She wants to know how long for the migrating ones, how far can they go, and how many life cycles. Oh, that's what we're hoping to learn.
So we're really at the very beginning stages of even finding out about their migration. They did put some radio tags on them on the East Coast, and they said that they followed the same routes as raptors, but as I said earlier, I'm pretty sure the raptors are following the routes of the dragonflies. And what they do is they will, this is for common green darners, I should say, they will stop in places and feed for 2 or 3 days, and then fly for a day or two, and then stop and feed for a couple of days. That's what we know. For common green darners, the migration is they will fly south, and then they'll do a life cycle there, and then fly back north, and then some stay in the north depending on when they hatch. And then there's the ones that are storm chasers, which is a different, it's like migration's kind of a odd word to use for that, but we don't have good terminology for that. So they chase the storms, the monsoonal storms in the desert especially. And then we have the ones, the Pantala, that do that India to Africa route, which takes several generations. I don't think we know necessarily, kind of like butterflies, we don't know exactly how many generations it takes to get from here to there. It depends on temperature and food and everything else along the way. But we just know that they somehow, this is one of the amazing things about nature, they somehow know when they hatch which direction they should go. And
So-
they just go.
Dave and I've had the experience in the fall of being on a river and watching the tramia, the saddlebags, coming down a feeder creek, hitting the river, and then going down the river. And we're not sure what that's about.
Right, we're learning. We just have all this anecdotal information. I've seen several swarms, especially in the inland mountains, where they'll go over a ridge and then go down the river and go over. And you know, you're driving along, you just see 1 or 2, and then you stop at the construction, and you're like, oh, there's 5. Oh, there's 10. Oh my God, there's thousands of them, all kegged up in the river canyons. And we don't know where they're exactly from. We don't know exactly where they end up. And then Dennis Paulson and I have been arguing over whether one species actually flies over the ocean. He says, oh no, we only get them at the beaches and the easterly winds. I'm like, yeah, but they disappear in Oregon. And I have fishermen telling me about all of these dragonflies over the ocean and anecdotal information from along all the islands along California. I'm like, I think they're island hopping. And he's like, oh, I don't know about that. So we honestly know very little about their migration, and they have many different versions of migration depending on species.
Dave, do you remember the time when we were driving up 101? No, it was I-5, getting near Mount Shasta, and we had darners coming down the highway. It was like our second year in dragonflies. We didn't know what we were seeing. Gosh, I wish I could see that again.
We have a question back there.
One question on Zoom.
Oh,
Question from Erica Fielder, who says, if wings in flight pump oxygen into the thorax, how does the emerging dragonfly pump itself up without pumping wings?
oh, well, that's because they're not pumping themselves up with air. It's actually their quote-unquote blood or hemolymph, and it's the very same process that butterflies do, where there's a chemical reaction that increases the volume.
Okay, within a family, do the species crossbreed, or they only mate with the exact same species?
There's very little crossbreeding. There is a little bit here and there, but in general, there is not. The one place where I would say there's a decent amount of crossbreeding, which is still very rare, is the same place as birds, and that's the continental divide, where you have the eastern species and the western species kind of coming together. So like the western plains, and down in Texas, you get some really weird stuff down there. But in general, they do not.
Right, because you said the males kind of have a pattern, the males and females have a lot.
Right. Yep. And there are like a couple of damselflies where it happens somewhat more commonly, and when you look at their appendages, they're very similar. So it can happen, and we don't know if that's because they've converged and had something similar, or if they were the same at some point and they're diverging. We have all of that same stuff with dragonflies and damselflies.
How would we know that it just said, I think you said 300 million years ago or something like that, 3 million years ago? How would we know that?
I leave that to the paleontologists and all of that. But they do have fossils. And then
And they
dating.
were big.
Oh, they were
Maybe
huge.
Size of a gull.
Yeah. But remember, there was a lot more oxygen, and the air was a lot more humid, and so a lot of things shrunk in size from that time because the air was different than it is today.
Right, in the Carboniferous, there were dragonflies with 2-foot wingspan.
Correct. Yeah. 2-foot wingspans was common.
From what I've read, the main change over all of its time, besides this shrinking in size, is their wing venation has become more complex. Yeah. And so it's not only that their wings are individually muscled, Sandra alluded to this, but like there's 2 muscles for the wing.
Yeah.
And they can actually raise one edge and put another edge down, or they can do some pretty amazing things.
Yeah.
We don't like them at all. Yes.
So on the wing veins,
Yeah.
do they do anything? Are they actually veins? Are they pumping the body fluid through them? What do they do?
So the wing veins don't pump any kind of blood or liquid. Once they harden, they're set. So think of them as structure.
Okay.
You know, and so the shape of all those little squares and circles and the thickness and all of that change the way that when they tighten their muscle, like it changes shapes and density and tautness, and so that affects the air differently. And then they all have a stigma, which is that dark spot near the tip, and that's kind of like it creates a different kind of stiffness at the front, which allows them to have longer wings than if they wouldn't have been able to. And so that's it's super aerodynamic. And then the other cool thing is they're antibiotic, naturally, structurally antibiotic, and so they're actually trying to look at if you look at them under an electron microscope, they have these little spikes all over them, and it causes the bacteria to explode. And so, excuse me, and so they're looking into being able to copy that for, say, hospitals, so that you wouldn't have to always use chemicals, and then the bacteria wouldn't become chemically resistant to the bacteria. So there's some really neat stuff coming out.
So several people mentioned having ponds. So I do want to mention that if you have a dragonfly who emerges wrong and his wing gets bent, you can cut that wing off. And it can fly fine with 3 wings. But it cannot fly with a crumpled up wing. So that's just a sidebar there.
How did you find that out?
I think there's another Zoom question.
Well, actually, if you could for me, I think there's some people who don't know how to navigate the chat. Can you just let them know that, hey, if you have any questions, please put it in the chat so we can read it out loud.
If you have any questions out there on Zoom, you can put it in chat and they'll call it out here for us.
So they have all these eyes, but they don't have a central nervous system. How do they catch another?
The same way flies do, just better. We don't understand that system in the way, we can't fathom it, right? So they're basically a supercomputer in essence that somehow hive mind-like, I guess, their eyes. But they can see, not only can they see all the flickers, they can see the UV light and the polarized light. And one of the ways they find water to find new ponds or new waters from where they emerged, is they can go fly really high and they can see the way the light splits from the water. So the UV light comes down, hits water, bounces off of it, splits in a very specific pattern, in a very specific way. So they can look and they can see there's water over there, there's water over there, there's water over there. Now, what else looks like water? Asphalt, fresh asphalt, brand new cars that are nice and shiny and clean.
They've actually formulated car paint to withstand dragonfly egg gel.
Right, and actually, when I went to the New Mexico Blitz, I'm one of those people that drives for hours and hours and refuses to stop. But then you get so tired, you pull over. So I pulled over in the middle of the desert, and I had a nice clean car, which is not very often, but that day I did. I took a nap, and I woke up, and I had like 100 dragonflies circling my car. They thought that there was a new source of water. And in the desert, that happens a lot with those monsoonal storms. They get new patches of water, and so they specialize on finding these small patches of water. So it's pretty amazing. And also when I've gone up in the mountains and I go and work, and I come back to the truck, and I have a darner making circles around my truck.
We had a cardinal meadowhawk who claimed the car hood, and we felt so sorry for it.
So anyway.
When they lay eggs in river water, do they attach to something? Why wouldn't they just be flushed on down the stream?
Good question.
Well, some of them do lay eggs in stems.
Damselflies, but clubtails.
Darners. Oh, cuptails. Yeah, well, yeah, I can't really answer the question of how the eggs don't just go downstream. I suspect that they're sticky at some level, and some of them do lay them like in crevices and such. I do know like sand dragons actually burrow once they hatch, and they hatch pretty quickly. So yeah, that's just more research to be done. It really is amazing how little we know. We're a good 200 to 300 years behind birds, on knowledge. Just basic knowledge, like which ones migrate and where do they migrate and why do they migrate and what type of migration. That's
And we're
just
behind Europe.
migration.
We're behind Europe, and we're behind the East Coast, what we know here in California. So
Well, yeah.
we're trying to change that.
Yes, we are.
The next time I see a dragonfly, I'll pay a lot more attention.
Yes, absolutely.
We call it giving you ode fever.
Yes, that's what we call it. I have ode fever, and I do not want to be cured.
Ode being short for Odonata, the family name. Not the family name, the order name. Well, you've been a wonderful audience. It's been our delight to present to you.